Hi cavers, this is John Lyles. Not only am I a caver, I'm a cave landowner now since 2018. I'm going to talk about Edgewood Caverns and talk about real-time carbon dioxide monitoring system that I'm designing to install in the cave, and I'll talk about the cave a little bit and the CO2 issues that it has. It's on the southern edge of Santa Fe County near Interstate 40. It's about 30 minutes east of Albuquerque in the town of Edgewood, and it's a dry cave in Pennsylvania limestone that's developed along an extensive east-west network of joints in the Madera Formation. This limestone is completely submerged underground there and doesn't pop up until you get towards the mountains. The cave experienced epiphyreatic development as the water table varied in the Estancia Basin, and as the water table drained and now is at least 300 feet or below that, because there are two wells on the property and both are dry. So all the wells in the neighborhood appear to no longer be functional, and as the water table is dropped, and there's a commercial water well down the road that's supplying all the water. It's a lot deeper. Speleothems are relatively sparse in this cave, except for subaqueous calcite crust and extensive rafts, and some of the rafts are spectacular in this cave. It also has chambers with extensive fossils from the Pennsylvania limestone. The cave is entered via a single 38-meter shaft, which is about 125 feet deep. It's drilled and cased for the first 80 feet with a 19.5-inch ID steel pipe from the top. A new visitor center was built to protect the entrance in 2018 by me with help from a contractor. The entrance shaft is challenging for some cavers, but there's an additional challenge in the cave that I'm going to talk about. Here's the visitor center and the Modesty changing area fenced in, because we're right by a highway in a neighborhood. And you can see the coyote melon plant growing there. Those are typical whenever you disturb the soil in New Mexico. Those take over. And that particular plant has taken over that whole area twice now, and I keep beating it back and cutting it back. The cave has extensive or impressive barometric wind, as often felt at the entrance. This is the cap on the entrance when you open it, and the doors open of the building. And the cave is blowing in this case because it was during the summer or the fall, and there was low pressure on the outside. So here's what the cave map looks like as of date. It's 5.2 miles of surveyed passage. The cave was originally around 3 miles with the old 1970s map that Robbie Babbs was working on and updating. And then when they stopped, they left a lot of potential areas to look, and Garrett Jorgensen has been in there about 38 times now and really pushed it, and this is the map he has created. So the new area is up on the upper left corner, the northwest corner. That's Donald's Lost Duckway, and that has going leads in it, but it also has CO2. The whole cave has CO2 issues, but that is the highest concentration I can tell so far. But we need to really characterize that to be sure if it's that low area. But CO2 gas is 1.38 times heavier than oxygen rather. It's 1.57 times heavier than nitrogen. And it tends to pool up in low areas if it's not mixed and diffused by air movement. But in Edgewood, it may actually emanate from these low levels. And so it would rise up and work its way up till the level of the entrance and then exchange with the outside. So it appears to be that's the case. And when you open the entrance and open the shaft lid, the air mixes better, so that the air, you can feel the air blowing in the passage, especially in the A survey in the main route. The oxygen level may drop below 19.5% in some CO2 caves, but this is not always a good indicator of high CO2. There could be another reason for that, like nitrogen or something worse, carbon monoxide, methane, or hydrogen sulfide. But But the oxygen level is a good indicator of any lower than 19.5% becomes a little more difficult to breathe. So it's good if you can look at both with O2 and CO2. And here's an extreme example. Vanishing River Cave in the Guads measured 9% CO2 and 4.2% oxygen in a 1997 trip that Jeff Forbes led that I was on. And that was really amazing. And you wonder what the rest of the gas is. And Jeff has some fairly interesting analysis and discussion on that in his trip report. But to go on, there's generally four recognized ways that carbon dioxide can form in caves and underground. One is organic decomposition of matter, such as in Vanishing River Cave, where there's earthworms and leaves and things that have washed in the entrance and gotten to the lower levels, and there's a sump down there, so the air gets stopped by the sump, and so it builds up in that level. There's also groundwater degassing with limestone dissolution, such as when calcite is forming in a cave. This is very common, and it's all the time happening in caves and limestone. And Fort Stanton Cave had some active CO2 monitoring equipment near Turtle Junction at one point because they were interested in how the calcite's forming and what's the CO2 doing at the same time. Deep-seated sources captured in structural features. This seems to be what's happening in Edgewood. In the sandstones of the underlying Sandia Formation seems to be a trap for the CO2 that's coming from deeper, from the water table or down in that area and coming up. And the Sandia Formation is below the Madera Formation in this Pennsylvanian series. So another source of CO2 is common is the hydrothermal waters, such as the Rio Salado area where Penasco Springs pits are, where the spring pits are to the northwest of Albuquerque out near San Isidro. Torrance County, which is just south of Santa Fe County and east of Bernalillo County on that corner there, has a water well that was drilled in 1928. And it was discovered that there was a very high level of CO2 in that well at 1,200 feet under the pressure of 415 pounds per square inch. So Witt Ice and Gas Company, located in McIntosh or near McIntosh, produced dry ice from two wells in that area that they drilled between 1934 and 1942. And it was claimed to have the potential for 2.35 million cubic feet of CO2 a day out of those two wells. But the pressure was not high enough to expel the water that seeped through the casing of those deep wells, and it eventually was discontinued, and Witt moved to the northeast corner of the state to a more active region, and they're still in the business, I believe, of CO2 wells. But this was the first CO2 plant in the state to make dry ice from carbon dioxide. And it's about 16 miles south of Edgewood Cavern, as you can see here on the mark I put on Google Earth. And McIntosh is to the right on Highway 41. Just south of McIntosh is a tiny village known as Witt. Other wells in the area of Edgewood also show the gas. This is common in water wells in the area, that there's air blowing, and if anyone measured, there would be CO2. One landowner that I heard of recently talked of building a greenhouse over his bubbly water well that he drilled recently, and it's about a mile north of Edgewood Caverns. Chili Hills Restaurant, which is on Highway 344 right off the interstate, has a very effervescent tap water. If you ask for a glass of water, it tastes like club soda, and I believe they get that water from a well. There's a dry water well in the Old Farmer Ranch, a fairly large diameter cased well that I found. It's about a half mile south of Edgewood Caverns, and the air blows synchronously with Edgewood Caverns, and it also has tested high CO2s when it's blowing. So the concerns are that we are seeing levels as much as 2% measured in the deepest cave passages during low pressure weather events. It could even be higher, but that happens to be the event we captured right before a thunderstorm in 2019. And Kevin Manley and I were measuring it as we were putting a rope to get down a fissure to get to Donald's Lost Duckway area. With the entrance being vertical and tight, anxiety and labored breathing seems to be common among first-time cavers coming out. Once you've gotten used to the cave and understand that you're going to get out fine of that entrance, then you get over that anxiety, but you still can have labored breathing if there's a lot of CO2 blowing up. And if you add the CO2, that can create physical problems with some cavers. So anyone with COPD, asthma, heart issues should not be in the cave. This is the exposure limits from several government websites. The National Institute of Occupational the National Institute of Occupational Safety and Health has recommended airborne exposure limits of 5,000 parts per million, which is a 0.5%, averaged over a 10-hour work shift, and at 30,000 parts per million, which is 3%, don't exceed a 15-minute work period. The American Council of Government Industrial Hygienists has similar limits over an 8-hour work shift, and they have a short-term exposure limit, again, of 3%. Vertical gear needs to be optimized in this cave for short strokes. So we examine that very carefully. If you're going to go join me or Garrett on some work trips in the cave, we have to know what kind of vertical gear you're using and make sure it's been tested and optimized, because if you're down in there and you try to get your rope walker out and it doesn't work very well, that's not a good thing. Mitchell, kind of a pseudo-Mitchell system seems to be the best we've discovered, but other people have their favorites. And the whole point is that your legs aren't able to stroke very far, so you have very short strokes. And you just have to take your time ascending and breathe and don't hyperventilate. Some cavers should avoid entering the cave, and I mentioned the types of health conditions that would be bad if you had an excessive CO2 issue. So what am I doing anyway? I'm going to install a monitoring system using a commercial CO2 sensor, and it's going to be placed in the cave this winter, COVID willing, that I can get some help and get in there and install this thing. And then I have 3 portable gas monitors now that can be carried while caving in the cave. Not all 3 at once, but 3 different ones to pick from. In 2019 at the Southwest region, I got the Patty Dog grant for some supplemental funding to buy some of this CO2 instrumentation. It bought one of the portable instruments. But the handheld gas monitors, they do provide a real-time safety monitor that can alert you with an alarm to leave when the level that you're in is excessive. And in my experience in the deepest part of the cave, I actually got a little bit of a headache, and I knew, and Nikki Woodward was with me, and we both felt headaches. So we knew that something wasn't right with the air down there, and it had to be CO2. But if you have a monitor to go off, that's even better. And the only problem is we really don't want these units bashed up and destroyed in a cave pack, so they have to be in a Pelican box, which means you're going to have to turn them on and off at regular intervals in places in the cave. The continuous sensor that I'm planning to install is going to provide real-time data to support scientific studies, and it'll also let us know if there's a good day to drive, for me, to drive 70 miles to Edgewood to work in the cave or not. And it will also have a local readout in the, quote, visitors center. There is scientific potential for having this instrumentation in the cave, and this cave in itself is very unique because it's such a CO2 source, and not to mention that it's probably contributing to climate change. The micrometeorology of the cave, of the air movement in this cave, can be correlated with other measurements such as the atmospheric pressure, the temperature, and wind velocity, and this may help predict when the CO2 is going to be worse. Also, when the CO2 is low and what parts of the cave the CO2 is high and low in. CO2 production can be correlated with seismic events in the earth and possibly monitored in real time to see if there's a change. Carbon isotope ratios from the CO2 would be useful to understand the source better, if it's from volcanic sources or what. Chemical analysis and measurement of additional gases such as helium, radon would be interesting. And I am really looking for academic interest through UNM, New Mexico Tech, and other academic institutions because this has been 2 years now, and I'm finally setting up this monitoring system. But I'm totally open to having uh, students involved and some research projects to really learn more about this cave because I'm pretty excited about it. The initial CO2 measurements that were made with Dave Decker's meter that Garrett Jorgensen borrowed in 2016. And after that, I made measurements in 2018 using a Telair 7001 air quality meter. But those meters are typically used for building air quality. They're not safety meters, so they're not capable of going above a little under 1%. In this case, these particular devices, their accuracy degrades above 5,000 parts per million, and that's a 0.5%. And here I show a Hobo U12 data logger connected to gather temperature and CO2 reading, and I'm lowering it into the cave with a bucket. So I installed a mechanically operated ridge vent shortly after the building was built when I discovered that there was a lot of condensation and dripping in the building off those steel beams. Now, those cold steel beams were rusting rapidly and leaving wet spots all over the building on the floor, on the concrete. So once I put that vent in, I leave it open. That dried out the building quite a bit and let the moisture out. It also I just close the cap on the shaft when we're not caving, but I leave the vent open all the time. And then in the winter, we close the vent because of the extreme cold air falling into the shaft when the cave is inhaling, and that when there's like a high pressure outside, then it's very cold trying to come out of the cave with that cold air blowing in. So we'll close it and then open it again after a person reaches the top. The first person, of course, gets the cold, so we keep it. We do open it while we're in there. The first person climbs up, it's cold, closes it for the next person. So first person is Garrett. And so here's an example of the measurement I made when I had it in the bucket, and the blue curve is temperature as I'm lowering into the cave. The black curve is the CO2 level going up as I lowered the bucket. And I didn't lower the bucket at a uniform rate, so you can see there's a couple of bumps in the curve. It would have been more of a straight line as it was going down. But you can see that when I reached the bottom, the bucket settled on the floor. It started settling out, and we're about 770 parts per million. And then when I opened the ridge vent on the top, you can see the drop there. So it made a difference. So as I said, the Telair meters are not very useful for safety measurements. They're more for scientific measurements in very low levels of CO2. And the one on the right in that photo, you can see the meter's reading 9999 parts per million. Well, that's just under 1%, and that's the maximum it can read. And I have no idea what the real reading was at that point, but you can see the cave temperature was 57.4 degrees Fahrenheit at that point. That was in the cave. There's about a dozen or more companies making good CO2 monitoring systems and portable instruments. The permanent systems are made for breweries, chemical plants, greenhouses, and for confined work in industry and government labs and things like Los Alamos. They all use non-dispersive infrared technology to determine the gas concentration. That's pretty much the standard anymore. And the older type instruments of maybe 10 years or older used incandescent lamps with filters, so they had a lot of power consumption, and they weren't that good in terms of reliability because the lamp came on and off and eventually will burn out. The newer units have infrared LEDs in them. And some of the portable meters have an electric pump, so you can hear them running, and those are very fast acting, and they have a hose so you can plug it, push it into a place such as we used in Vanishing River Cave and take a sample without actually having to hold the entire meter in that area, which would be very dangerous. The others just have natural diffusion, and they take a while. So one of my meters has a pump, and the other two are natural diffusion. And there's a simple qualitative device called the EasyCap 2 that is being tested right now in Texas when some of the CO2-rich atmosphere caves. And it's basically a special paper with some chemistry that changes colors and when it's in a high CO2 level. And Sarah Truby of Edgewood Cavern showed me this and gave me a paper on this, which I mention later. The calibration, this is really important for measuring for safety, because if you have an instrument that seems to be working but it's lying, it's as good as no instrument at all. And so if you're going to trust these instruments for, making a determination to leave the cave or stay in the cave, then you should calibrate them regularly. And it doesn't have to be every day, but it can be to verify they're working, especially a system that's sitting in the cave like this, where it may get corroded from the moisture of the cave air. So it will require a 17-liter cylinder, which is about the size of a propane hand torch cylinder, carried down in the cave with reference gases, one being nitrogen, so that would be a 0 reading CO2, and the other one with about a 3% CO2 mixture with nitrogen, or 5%. Those can be brought in, and a small regulator is on the cylinder. I have that now, so that you don't just flood the cave with nitrogen while you're in there. You just let a controlled amount out in front of the sensor. A second person has to be up on the surface. These cylinders, by the way, are available from Amazon and Granger and places like that. So the caver on the surface will put the local readout into calibration mode, and the person in the cave will then admit the gas in front of the sensor, and the person on the top will then adjust to read what the gas mixture is. And to do this and coordinate it after you've gone in the cave, you could use a clock and say wait 15 minutes. I can also put an intercom in. As you're going to see in a moment, I have a way to get cables to the sensor. I also can just put down a twisted pair and have of wires and have a regular little cheapy battery operated intercom, so we can say, okay, I'm at the sensor now, I'm going to calibrate. So and day to day, there will be some fluctuations, and that'll be observable, so I can see if the system is working. If it goes flatline, then there's a problem. The portable meters are easy to check, because outside they run around 400 to 450 with open air. That's the typical level of carbon dioxide in open atmosphere, unless you're next to a volcano. So these are the 3 meters that I'm currently in possession of. They all came from eBay, and I wait until the price is right. This one on the left is an older model, has a pump in it. It's an ISI CDU 440. The middle one is a really nice meter, an analog sub-aspida, which was actually made for submarines, and that's why they call it the sub. And it measures CO2 and oxygen levels very accurately. Those are the 2 sensors. You can see the 2 little spots on the top. And then the one on the right I just got this week. It's a SAN 10. Sarah has used these a lot in her work, Sarah Truby, and this unit I think I got for 90 bucks on eBay last week. So that'll be the 3rd one to complement what I have, and it only reads CO2. But those meters need to be kept in a Pelican case because they're pretty fragile and kind of expensive. This is the full sensor that will go in the cave, the 5S Mark III from Analox. It runs from 0 to 5% CO2. It has an analog current loop output, so a pair of wires can carry the signal up to the surface a long distance to a remote readout, and also to a system that'll put it on the internet. I'll show you that in a moment. This is an older system that I got that's not very good because it has an incandescent bulb that turns on and off inside, but it reads through a digital connection instead of an analog loop, and it unfortunately has a limit to how far it can be, and I don't believe it'll work down the well pipe. But I haven't tried it, and it doesn't look very robust. This is the device that connects to the internet. It's an IoT, the Internet of Things is what that means, gateway device, and it'll upload the current loop signal as a digital number into the cellular network using LTE. You know what LTE is because many cell phones have 4G LTE is one of the modes they operate in. Well, there's a subservice of that allows you to send data for, oil well pads and equipment, talking to other equipment, and telemetry and other kinds of systems use this LTE data. And this little device here, the Connect sensor, will put it on that network. So I'm paying $4 a month for a service to use this, and it actually can operate on a time clock or can be turned on remotely via the cloud. I can go on and get onto its server and the server that it's talking to and talk to it. This is how the cables will go down to the sensor. This is an old water well, the original discovery well for Edgewood Cavern. The cave was found when they drilled this and hit air and hit a void and dropped the bit. So this is a dry well now, and I've cut a hole in the casing down at the bottom in the cave passage where it goes across the entrance passage. Just after you get off the bottom of the shaft and you go about 20 feet down, you reach this, and there's a place I can bring the cables into the cave this way. I have solar power hooked up on the building now with a solar panel, and it's charging a sealed lead acid battery in there. And this is some other ideas about high CO2 caves. And Peter Sprouse talked to me about a month ago as he was working at Malpais with Gene Creech, and he came by on his way back and wanted to see the entrance to Edgewood Caverns, so I took him there and we had a nice chat. And he said that in some of the caves in Texas they actually will rent or have some big gasoline powered fans that they put near the entrance to suck the CO2 out and force air in with a hose. Only thing is, I don't know if this would work so well in Edgewood, where the gas seems highest in the deepest western chambers, which is a long way from the entrance. And also there's a high level in the eastern end where it's deep as well. That's not so far from the entrance. But it may be more effective to have another well breaching the cave in the west to allow circulation all the way through the cave, either forced with a fan or natural. But in order to prevent long-term impact to the cave, such as drying out and letting things in the cave, this would not be left open. It would have to be done intermittently during or before work trips to evacuate the CO2 and bring fresh air in. And then it could be closed again. This is just a proposal that I have been mulling about in my head. It's unfortunately an expensive way to solve the problem. And here's an example of what I was looking at. The cave entrance is on the right where the arrow is in the little cul-de-sac. And then if you go down Dinkle Road, the piece of property sitting there idle has nothing on it, and that property happens to be right over some of the more dense part of the western passages. So one could drill a well in there with a small diameter pipe and admit air and let that be a way to breathe. You would want to put some kind of screen or filter on it, or possibly build a little hut over it to protect it. So here's the entrance with the hoist. You can see how we go in. We don't use the hoist anymore. We actually have a single rope behind that we use, and us going in on one of the trips a couple of years ago. So here are some references that I want to share. You can stop the show and look at them and read them and look them up if you want to know about carbon dioxide in karst areas and in caves. Also, there is some connections to radon 222 mentioned. That's kind of an interesting subject in itself. And here's more references, and I'll hold this slide. And that's the end of my show, so I hope that was interesting.